greet you once again and thank you for attending our today's session. This is TV Math Hub, and I will be basically taking you through our today's session. My name is TV. That is my simple name, and I will be the one to take you through our today's session. For those that have joined us for the first time, you are welcome, and make sure you don't miss our next session. So you need to keep alert all the time, so that we are able to move at the same pace. So generally, we started differentiation 2. That is in our previous session. So in case this is your first session, then there is a video that I already uploaded on YouTube. So you can check. That video is there. If I can maybe take you through that in a very quick time. So you can go and check us through that video there. So, so basically you just type on YouTube TV Math Hub and it will take you to this platform here. And from this platform you'll be able to get the one that we have already discussed, that is differentiation of trig functions from first principles. It is here, this video here. That is the one that we basically discussed last time, differentiation of trig functions from first principles. So in case you missed that video, please go and check for that video, watch and get to know how we differentiate from first principles. So don't forget to subscribe and like this video and to share with your friends. So for that case, let us come to our today's session. So our focus will be on the recap of what we did last time, and we look at the continuation. So we shall revise some key ideas from previous lesson. Then we move to some more exam style questions, and after that we shall look at the differentiation of inverse trig functions. So all these are built directly on the differentiation 1 that you covered in senior 5 and the earlier differentiation 2 that we talked about last time. And basically our objectives for this lesson will be for you to recall some results for differentiating trig functions. You should be in position to apply differentiation rules in different questions, and by the end of this lesson you should as well be in position to differentiate inverse trig functions. So I still believe you have the knowledge about all this, that is getting the gradient of a curve, chain rule, how to use product and quotient rules, how to deal with implicit differentiation, and some of these applications. So you should have studied this by senior 5 term 2. But still, even if you don't know, we shall be recalling some of the important concepts from all this. So basically in differentiation 2, results must be justified. So the proofs you need to be able to provide the sufficient proofs based on the steps that are required, not to just jump from anywhere and you put a proof there and you say it is as required. So you need basically to understand how the concepts are related, such that you don't just cram. So differentiation from first principles majorly explains where the results come from that we looked at and that we shall be looking at. So when you look at some of the key trig identities that we used the last time, we used the factor formula and some of the expressions from compound angles. If you recall very well, those are some of the expressions that we used last time in our previous session. Basically, we looked at the differentiation of cos. We were able to come up with the derivative for cos, whereby we said when you differentiate cos, you get negative sign of x. And at the moment, I believe you know where that one comes from. It is not by cram work. We proved that one last time. So you need not to neglect this negative here. It is very important. If you miss this negative, then you will have given a wrong derivative. So the negative sign is so important, so you should not miss that one there. We also looked at the differentiation of sine of x, whereby we said from first principles, when you differentiate sine of x, with respect to x, you get cos of x. We also talked about that. And the other trig functions that we looked at, we looked at the differentiation of tan, differentiation of sec, which is same as sec x tan x. Differentiation of tan was sec squared of x. You should be able to know where these come from. Differentiation of cosec, where we said it is negative cosec cot, and differentiation of cot, where we said it is negative cosec squared of x. Please, you need to be having these ones here at your fingertips, because not all the times you will be differentiating from first principles. So you should be knowing, when I differentiate tan, what do I get? When I differentiate sec, what do I get? When I differentiate cosec, what do I get? When I differentiate cot, what do I get? So you need to be having some of these results with you. So basically, that is what we discussed last time, how best we can differentiate trig functions from first principles. Maybe in case there is any questions regarding what we did last time, you can put it forward. Otherwise, we shall look at some of the exam style questions and how we can easily go about them. So we shall start with a few questions, and after that we shall be able to look at differentiation of inverse trig functions. Okay, so let us look at some few questions here. So one of the questions, it says differentiate with respect to x, y which is equal to x sine of x. So we need to look at that. So we need to look at the differentiation of y which is equal to x sine of x. X sine of x. I believe for those who were there last time, you should be able to guide us on how to do this one here. For those who were there last time, is there anyone who can be in position to get the y dx here? So can guide us on the required steps. So if you are there, please try to unmute and lead us through that one there, because we looked at some similar questions. So you should be able to take us through this. Anyone, please, you can let us know if you are there. Yes, anyone? Oh, it is very tricky for us all. If you are there, please lead us through this one here, through the steps which are required. I'm waiting, I'm waiting.
X cos of x divided by x is equal to x cos of x.
Is x cos of x? Please take us through the formal procedures. What do we need to do, and at what step are we supposed to bring it? So those are the steps which we are requiring at the moment.
We differentiate x and we also differentiate sine of x differently
Okay,
by applying.
Okay.
So our x will be u and sine x will be v.
So what we do, we first rate u to be x and v to be
sine of x.
Sine of x.
So when we differentiate u,
when we differentiate u with respect to x, we
then
shall
it
get
will be equal to 1.
We get 1.
Yes. When we differentiate v, it will be equal to cos of x.
So when you differentiate sine of x, you get cos of x. So this will be cos of x. Okay.
So we apply. They call it the quotient rule or product. I don't know. Quotient rule.
Quotient rule is for when you are having when you are having a quotient, a fraction, when you have like, if it was like x over sine x, that's when you apply quotient. So this is the product. This is a product of two functions. Okay. So we shall apply the product rule. So how do we state the product rule? If you have your y as, if you have y as uv, where v and u are functions of x, so how do you state dy dx?
Y by dx is equal to v.
It is equal to u dv.
So it is u
over dx
dv dx
plus v du over dx.
plus v du over dx. Okay, so
Yes.
that is what we call the product rule. The product rule is applied when you are having two functions multiplied together. So you are having u and v as you had read here. This is representing your u, this is representing your v. And after that, then you should be able now to substitute for u for the v dx, then v and du dx. So basically that is what we do. So from this given point, after noticing that this is your product, then you will get your du dy dx, and your dy dx will be u. Our u is x, so this will be x. dv dx is a cos of x. Then we shall add there v is sine of x, and then you will multiply by du dx, which is 1. In other words, you'll be able to get x cos of x plus a sine of x. So this will be your dy dx. So you can easily see that when you know how or what you get when you differentiate trig functions, it will be easy to deal with different questions. So basically, that is what we do. So that is what was required for this question here. So differentiate with respect to x, y equaling to x sine of x. You should be able to do that. Next question is about the quotient rule, not product rule. So this should be quotient rule. So this is about quotient rule, and this is what we are given. So last time we looked at how we can differentiate trig functions with multiple angles. So this should be easier for us at the moment. So let us look at how best we can deal with this expression here. We are given y equaling to 1 plus sine 2x divided by cos 2x. So that is what we shall try to look at. So we are given y as 1 plus sine 2x divided by cos of 2x. And what we are interested in is getting dy dx. So at the moment, when you look at this given expression, you should be able to realize that this is in form of a quotient. So what you do, you have to let this one to be your u, you let this one to be your v. And if that is the case, then now you should be able to have this as u equaling to 1 plus sine of 2x. Then at the same time, v should be your cos of 2x. So we shall differentiate u with respect to x. This is same as differentiating with respect to x, 1 plus sine of 2x. So when you differentiate 1, you get a 0. What do you get when you differentiate sine 2x? Anyone to give us the answer there? When you differentiate sine 2x, what do you get?
Cos.
You get?
We get 2 cos x.
You get 2 cos
X. Cos 2x.
Cos 2x. Okay, thank you. So basically, when you differentiate this expression, you differentiate 1, which will give you 0. When you are differentiating sine, as we said, you differentiate this angle here. So when you differentiate 2x with respect to x, you get a 2. So this will be 2, then multiplied by the derivative of sine. The derivative of sine is cos. So this is cos, then you return the same angle. So that's why we shall have du dx as 2 cos of 2x. So this is du dx. Then we look at the v dx. What will be the v dx? The v dx will be same as, we shall do the same.
2.
Yes, so it will be 2 times. So differentiate this, get 2, then differentiate cos and get
negative sine.
When you differentiate cos, you get negative sine. So it means it will be negative sine of return the same angle, which is 2x. So in other words, this is same as -2 sine of 2x. That is what we get there as dv dx. So having got that, how do we write if you have y equaling to u divided by v? What is dv dy dx when we are talking about quotient rule? Anyone who remembers that? Dy dx, if you have y equaling to u divided by v, the
It
expression,
is equal
yeah,
to v du
it
dx
is v du dx
minus u
minus
dv dx u
u
dv dx
dv dx
over v squared.
divided by v
Over
squared.
v squared.
Okay, thank you. That is what we call the quotient rule. So for our case, we are interested in the y dx. So the y dx will be same as v. You have your v as cos of 2x. So put your cos of 2x there. Multiply by du dx. Du dx is again 2 cos of 2x. Then subtract u. Your u is 1 plus sine of 2x. Then multiply by dv dx, which is minus of 2 sine of 2x. So the whole of this should be divided by v squared. V squared is v is cos of 2x, so we should have this one squared. So that is basically what we are having. So from this given point, then we need to come up with the simplified expression. So we need to simplify this. So let us try to simplify this. This is same as 2 cos 2x times cos 2x will give us cos squared of 2x. Then we shall have this minus and this one giving us a plus. Then multiply this 2 sine 2x with a 1, get 2 sine 2x. Again, add it with, multiply this 2 sine 2x with this to give us 2 sine squared of 2x. So the whole of this should be divided by, cos of 2x, the whole of this squared. So that is basically what we shall have. So when we look at this, you realize this is 2 cos squared 2x, this is 2 sine squared 2x. So we can again simplify this further by having this as a 2 into a cos squared of 2x plus sine squared of 2x. Again, we are adding there, so we are combining this with this one. The 2 is common, so we put the 2 out. Then here we are having 2 sine 2x. So we are having 2 sine 2x. The whole of this, after simplifying this, the whole of it is over cos 2x squared. So this is divided by a cos of 2x, which is squared. So from that, anyone who can tell us what this one is equivalent to? If you have cos squared 2x plus sine squared 2x, what is it equal to?
1.
This is 1. So basically, we know from the Pythagorean identity, if you have cos squared of x plus sine squared of x, this is equal to 1. However, when you look at this, the angles are the same, meaning even if this is a 2 and this is a 2, still it will be equal to 1. Even if the angle is 3 here and the angle is 3 here, this will still be equal to 1. Meaning that if I have cos squared 2x plus sine squared 2x, it will also give me 1. So that is the criteria there. However, the moment this angle and this one are not the same, then you can't equate it to 1. These angles must be the same for you to have this one equal to 1. And this must be square. So cos squared of any angle, cos squared of that same angle must give you 1. So that's why we shall have this one equal to 1. Okay, so from there, we shall put there 1. We shall have this as 1. So this will be 2 plus 2 sine of 2x divided by cos squared of 2x. So this will be same as having 2 into 1 plus sine of 2x divided by cos squared of 2x. When you look at cos squared of 2x, cos squared of 2x can also be written as 1 minus sine squared of 2x. I hope that one is very okay for all of us. The reason is, as we saw here, we saw that when you have cos squared of 2x plus sine squared of 2x, it is equal to 1. Meaning if I have cos squared of 2x, I can still have it as 1 minus sine squared of 2x. So that's why I'm substituting for this. Likewise, this can further be simplified to give us 2 into 1 plus sine of 2x divided by, I hope everyone will be able to see that this is a difference of 2 squares. 1 minus sine squared. This can also be written as 1 square. So in other words, I can as well write this as 1 minus sine of 2x into 1 plus sine of 2x. I hope everyone will agree with us that this is a difference of 2 squares, which we can write as that. And from here, we can all easily see that from here that 1 plus sine 2x will cancel with 1 plus sine 2x. And this will be able to give us 2 divided by 1 minus sine of 2x. So this will be our dy dx. Okay, so unless there is a question, then we shall look at another question. So if you have any question regarding that, you put it forward, or else we can look at the next question. So that is how we differentiate some of these expressions here. So this was our question number 2, and I hope the procedures have been very clear for all of us. So the procedures we are following are still the same procedures you did when we were looking at the differentiation, especially using when you were looking at the differentiation of polynomial functions. So the procedures are still the same. But what is important here now is to know how we can now differentiate trig functions. Okay, so let us look at another question. This is almost a similar question. Y is equal to sine of x divided by x. You still use the quotient rule. So that should be very okay for all of us, unless someone is saying that that one cannot be easily done. But if that is very okay, then I want us to look at some other question. One more question. Okay, so let us look at another question. So the question says, let me write it here. So we have a function. So the question says a function y of x is defined parametrically by x equaling to t minus sine of t, then y is equal to 1 minus cos of t. What we need is find the y dx and to show that y squared the 2y the x squared plus 1 is equal to 0. Okay, so you studied about parametric equations, but not basically containing trig functions. So let us also look at some of such expressions. So you are given x as t minus sine of t. So what do we need to do first? What we shall do is to first differentiate x with respect to t. Because x is a function of t, so what we do, we differentiate x with respect to t first. And someone should be able to guide us with this differentiation. As we know, we shall be differentiating on each of these by what we call That is the differentiation with respect to t. So we are differentiating each of these with respect to t. If you want, you can differentiate it at once. So can someone guide us there? When you differentiate t with respect to t, what do you get?
1.
You get 1 minus differentiate sign of t with respect to t.
Cos of t.
You
Cos
get
t.
cos of t. So this is our dx dt. Okay, so next we are also given y is same as 1 minus cos of t. So what is dy dt? Dy dt, we shall differentiate this at once. So differentiate 1, you get a 0. So next, so what we are doing is differentiating with respect to t1. Then again, differentiate with respect to t cos of t. That is what we are doing. So when you differentiate 1 with respect to t, what do you get?
0.
You get a 0. Okay, then we shall have a minus there. Differentiate cos of t with respect to t.
Negative sign.
We get negative sign of t. So this will be able to give us sign of t because this minus and this will give us a positive. So the y dt will be equal to that. But remember our interest. Is to get dy dx. Okay. So what will be dy dx? How do we get dy dx if we have dx dt and dy dt? How do we get dy dx if we have dx dt and dy dt?
We shall do
Yes.
dy dt
So we shall have dy dt
times dt dx.
times dt dx. Okay, thank you. You should be able to see that this dt and this one must be able to cancel such that the left-hand side is equal to the right-hand side. So the two must be equal. So if you have dy dt, you must multiply by dt dx such that even if this one cancels, you still remain with the same expression. So don't put it as dy dt then dx dt. That one will be representing something else. So we have dx dt, we have dy dt. So can we go on and get a dy dx? So our dy dx will be dy dx will be dy dt. Dy dt was the sine of t. So this is sine of t. Then we are multiplying by
1 minus
dt
cos
dx.
of t.
Dt dx is same as the reciprocal of dx dt. Is that one okay? So dt dx is same as 1 over dx dt. Okay, so we shall put there 1 minus 1 over 1 minus cos of t. So in other words, we shall have this as sine of t divided by 1 minus cos of t. This will be our dy dx. Okay, we go on and have look at the part, the next part. Show that y squared d2y dx squared plus 1 is equal to 0. This is what we call the second derivative. That is the second derivative. So looking at the second derivative, so we need d2y dx squared. d2y dx squared. So what is d2y dx squared? d2y dx squared is same as, if you have the y dx, how do you get the 2y dx squared?
Find the second derivative.
You get the second derivative of the y dx. So you get the second derivative. So do we simply say this is d dx of the y dx? That is what you are saying? So this is a bit tricky when you look at this. When you look at the expression you are having, this is an expression in terms of t, not in terms of x. So when you are getting the second derivative, you will not differentiate with respect to x, but rather you will differentiate with respect to what?
T.
With respect to t. So when you differentiate with respect to t, then when you look at this and this are not equal because this is d2y dt dx. When you look at this expression alone, this is d2y dt times dx. not d2y dx squared. So the two are not equal yet. So what we do, we shall again multiply by dt dx. When you look at this, when you again multiply by dt dx, you realize that now this dt and this one will cancel, and you will have your d2y dx squared. So that is what we shall do. So when you reach here, don't simply differentiate with respect to x, because the expression you're having for dy dx is in terms of t. So what you do, differentiate with respect to the variable you are having, but don't forget to multiply by dt dx. So if that is the case, let us look at the 2y dx squared. So the 2y dx squared will be same as differentiating with respect to t, a sine of t over 1 minus cos of t. But we shall multiply this one with dt dx, which is 1 upon 1 minus cos of t. Okay, so for that case, let us look at how we differentiate. Let us first consider the derivative of sine of t divided by 1 minus cos of t. Let us first consider that. So we shall apply what we call quotient rule. So we shall let u to be sine of t. We shall have this as du dt, which is cos of t. We shall also have v to represent 1 minus cos of t, and this implies dv dt will be same as differentiate 1, you get 0, differentiate a cos, you get negative sine of t. So basically it will still give us sine of t. So from there, get your expression. So you are differentiating this. So the derivative of this one will be equal to, so we are having d dt of sine of t divided by 1 minus cos of t. So this will be equal to, so apply the quotient rule. So this will be v, our v is 1 minus cos of t, then times du dx, du dt for this case. So du dt is cos of t again. We are subtracting, so this is v du dt. I'm doing it at once, unless you want me to first write the formula. Then we shall have minus u. Our u is a sine of t, and we shall multiply this by dv dt. Is that one okay? Dv dt is sine of t again. And we shall have the whole of this divided by 1 minus cos of t, but this will be a square. Okay, so let us go on and simplify this. This will be cos of t. This will give us cos of t minus, so cos t times cos t will be minus cos squared of t, again minus sine squared of t, and you are dividing the whole of this by 1 minus cos of t, which is squared. And this can as well be simplified as cos of t minus, I can have this one into one bracket, cos squared t plus sine squared of t. We are dividing this by 1 minus cos of t, everything squared. Okay, so this is cos of t minus, this will give us 1. I hope you still record that. Divided by 1 minus cos of t, the whole of it squared. Can this one again be simplified? We can simplify this. This is cos t minus 1. This is 1 minus cos t. So I can create that one by pulling out a minus, and this will be 1 minus cos of t divided by 1 minus cos of t. But the whole of this is squared. So we shall go on and have this as this and this will cancel. One of it will cancel. We get negative 1 over 1 minus cos of t. I hope that one is very okay to all of us. Okay. So that one is very okay. If it is okay, then what we have got is simply this. Remember, we need to come back to this expression. So what we have got is for this one. So we need now to go back and have the 2y dx squared. So let us have the 2y dx squared. So from 1, the 2y dx squared will be same as this one here. What we have got is for this. What we have got is for this. So where there is this one here, I will put this derivative here, negative of 1 over 1 minus cos of t. But I'm multiplying by 1 over 1 minus cos of t. 1 minus cos of t. I'm referring to equation number 1, which is this. So where there is this one, I'm putting what I have obtained, and I multiply it with that. Okay, so we shall have this expression. So this is the 2y the x squared, which is actually equal to negative 1 over 1 minus cos of t, which is squared. Let us go back to what we need. So basically, we are talking about a function y of x is defined parametrically by this. We have got the y dx. Then show that y squared the 2y dx squared plus 1 is equal to 0. This is what we need to show. So looking at our y is representing 1 minus cos of t. And for that case, since we need to achieve y in our expression where there is 1 minus cos of t, we shall place there y. So let us go back, and where there is 1 minus cos of t, let us put y. So we shall have the 2y the x squared, which is equal to negative 1 over y squared. I hope that is okay. And from this, we can now multiply through by y squared. When we multiply through by y squared, we shall have y squared, the 2y, the x squared, equaling to negative 1. And looking at what we need a 1 this side. So we shall have y squared, the 2y, the x squared, then plus 1 equaling to 0. And this is the required expression. So basically, those are the procedures we follow when we are looking at differentiation, especially for expressions containing trig functions. The most important thing is when you are looking at second derivative, especially when your dy dx is not directly in terms of x. So don't simply differentiate this dy dx with respect to x. So if it is in terms of another variable, this is what you use. So you have to be careful there. Make sure that the two sides are equal. So that is our question number 3, and I hope it is very clear to all of us. So if that is very clear to all of us, you will, in your free time, try for me this question here. It is using almost related knowledge, so it should be easier for you. So you put this one down and try it out. See if you are able to come up with the answer. So it says, given that, so given that y is same as 1 over 1 plus sine of x. Show that the 2y dx squared minus 3y dx squared is same as, this is a 2 here. So you have the 2y, it is y, okay. It is y, the 2y, the 2y dx squared minus 2 the 2 dy dx squared is equal to y to power 3 sine of x. Is that one very okay for us? In case it is a bit hard for you, you will tell me in case the answer is not coming, but you should be able to prove it. So the most important thing is to know how to differentiate this. Actually, this can be differentiated at once. If you have y equaling to 1 divided by, you have 1 divided by 1 plus sine of x. You can easily get dy dx by simply first putting this in the numerator, and it becomes power negative 1. Or else someone can use a quotient rule there. But even if you don't use quotient rule, you might easily get the answer here. Simply by looking at this, then dy dx will be same as differentiate this one normally, drop the power, which is negative 1, reduce the power by 1. When you reduce the power by 1, it becomes negative 2, multiplied by the derivative of what is in the bracket. So the derivative of what is in the bracket is cos of x. So in other words, you multiply by cos of x. So you will be able to get this as negative cos of x divided by 1 plus sine of x, the whole of this squared. This is how you can easily differentiate it. And then when you are looking at the second derivative, then now you can apply the quotient rule, u and v. This other one can now not apply. So here you apply the quotient rule, and after applying the quotient rule, you will be able to come up with the expression. So here getting the 2y dx squared, this is very direct, and like what we did, this you simply differentiate your dy dx. Because what you are having here is already in terms of x, so you simply differentiate this. So try out that one, and see if you are able to have this one satisfied. That is, you should be able to show that y times the 2y, that is the second derivative, y times the second derivative minus 2 times the first derivative squared, same as y to power 3, then sine of x. So simply follow the procedures, get the 2y dx squared, and then this should be able to come easily. Okay, so you will try out that, and next we shall look at one more question here. Find the equation of the tangent to the curve at the point where x is equal to pi by 3. Okay, so we need to talk about equation of the tangent to this curve. I hope you recall how to get the equation of the tangent. To get the equation of the tangent, what do we need most? We need to get the gradient. And how do you get the gradient? When you are looking at this given expression, when you have y as sine of x, how do you get the gradient? Anyone to tell us how you get the gradient if you have y equaling to sine of x?
Differentiate y.
So it is simply the derivative of y. So the y dx is actually the gradient. So given what we are given here, we are given y equaling to sine of x. So meaning that you need the y dx, and this will be acting as your gradient. So the y dx is same as differentiating with respect to x sine of x. In other words, when you differentiate sine of x, you get cos of x. But we need the equation of the tangent when y is equal to this, but at the point where x is pi by 3. So at that point, when x is pi by 3, what will be at y dx? So when x is pi by 3, what will be dy dx at that given point? X is equal to pi by 3. So x equaling to pi by 3, this implies that we shall have cos of pi by 3. So what do we get there? Cos of pi by 3. So get for us cos of pi by 3. Pi represents 180 degrees. Pi is same as 180 degrees. So when we say cos of pi by 3, so pi by 3 is same as 180 divided by 3. So in other words, you are getting cos of 60 degrees. Okay, so pi represents 180. You can also put it direct on the calculator, but you have to make sure that your calculator is in radians, because pi is in radians. Okay, so what are you getting? Cos of 60 degrees.
Is a half.
Is a half. Okay.
Yes.
So we shall have y dx as a half. So this implies that the gradient of the tangent is a half. So the gradient of the tangent m will be equal to a half. So to get the equation, now to get the equation of the tangent, then we shall refer from the gradient, which is same as change in y over change in x, where x and y is a general point on the on your curve. So we shall have this as gradient. We have it as that. Then we have our x1 and y1. So we need also to get x1. x1 is a point that we are referring to as pi by 3. So we need to get the corresponding value of y1. So remember, our y is sine of x. Our y is sine of x. So it means y when x is pi by 3 will be sine of pi by 3. So which will give us y as, so get sine of 60 degrees. So that will be root 3. Are we getting that? Sine of 60 degrees.
Yeah.
Yes.
We get that. Okay, so from that we have the gradient as a half. You have y minus y1. y1 is root 3 over 2 divided by x minus x1, which is a half. So try to simplify this. So you will have this as a half into x minus a half, which is equal to y minus root 3 over 2. So what you can do is to multiply through by 2. This will be x. Or else you can simply have this as a half of x minus 1 over 4, which is equal to y minus root 3 over 2. So multiply through by 4, make life easier. When you multiply through by 4, you'll be able to get, this will be 2x. So you
Excuse me,
have
sir.
2x.
Excuse me, sir.
Yes, please.
On the other part, I thought our x is pi over 3, not a half.
Oh, yes. Thank you for that observation. Our x is pi by 3. A half is actually the gradient. Okay, thank you for that observation. So this is a pi by 3. Okay, so we should maintain pi by 3 here. We should maintain pi by 3 here. Pi by 3. Okay, so this will be pi by 6 when we multiply through. So this will be a half x minus pi by 6. Then y minus root 3 over 2. Okay. All right, so let us try to simplify this. So this will be a half of x. So we have a half of x minus pi by 6. Okay, so let me rewrite that. A half of x minus pi by 6, which is equal to y minus root 3 over 2. So we shall multiply through by 6. This will be 3x minus pi, which is equal to 6y minus 3. We are multiplying here by 6, here by 6, here by 6, and here by 6. So that is 3x minus pi equaling to 6y minus 3 root of 3. So we can rearrange this to have this as 6y equaling to 6y equaling to, I want to take this one this side, 3x minus pi 3 root of 3. So basically, this will be the equation of the tangent. So we needed the equation of the tangent to the curve. So this will be the equation of the tangent to the curve. If you want, you can go on and have this divided by 3 again, by 6 again. So you can even have this as 1 over 6 into 3x minus pi plus 3 root of 3. So this will be our answer, and that will be the equation of the tangent. Okay, so that is basically what we get. In case you have a question, you can put it forward. If it is not there, then we shall look at the next question. Okay, so let us look at the next question. The next question is about the normal, which I think you'll be able to try out. The only difference is when you look at for the tangent, we simply obtain the gradient by simply substituting directly for the value of x in dy dx. So when you are looking at the normal, if for example this is about the normal, then you must get the gradient of the normal, and the gradient of the normal is same as -1 upon the gradient of the tangent. So that is how we obtain the gradient of the normal that you will substitute here. So for this case, if we were looking at the equation of the normal, then what we would do after getting dy dx here, we would go on and get the gradient of the normal, and the gradient of the normal is same as -1 divided by the gradient of the tangent, the gradient that you have obtained here. So meaning we would have -1 divided by 2, which would give us -2. Instead of using a half, we would use -2. Then you substitute it here, have your y1, have your x1, then substitute, follow the same procedures, and you'll be able to get the answer. So what only changes when you are talking about the normal is after getting dy dx, then you get the gradient of the tangent, go on and get the gradient of the normal. So the gradient of the normal is simply the -1 divided by y dx that you will have obtained. So for that case, you should be able to try out this question here. Find the equation of the normal to the curve after getting dy dx, after getting your dy dx, and substituting x equaling to pi by 4. Please go on, that will be your gradient, but to get the gradient of the normal, you will get -1 divided by the value that you have obtained here. Then use again m, the gradient is changing y over changing x, and you'll be in position to get the answer there. Okay, I want us now to rush to something else that is basically to do with inverse trig functions. That is what we want now to come to within the remaining minutes. So I want us to look at differentiation of inverse trig functions. Having looked at the differentiation of trig functions, now let us see how best you can differentiate inverse trig functions. So to start with, we need to look at how do you differentiate sine inverse of x, how do you differentiate tan inverse of maybe 2x. So we need to look at that. So basically, you need to know that when you are talking about sine inverse of x, this is not same as 1 divided by sine of x. So meaning someone would say, instead of differentiating this one here, let me differentiate 1 over sine of x. That one will be wrong. So we shall look at how we can differentiate that. What is important is to know that this and this one are not the same. Sine inverse of x is not 1 upon sine of x. The two are totally different. Okay, so having looked at that, let us see how best then we can differentiate inverse trig functions. Okay. So basically, when you differentiate inverse trig functions, for example, you differentiate sine inverse of x, you will be expected to get this. When you differentiate cos inverse of x, you are supposed to get that. When you differentiate an inverse, you are supposed to get this. You must be knowing some of these results, because when you come to integration, you will be dealing with the reverse of differentiation. So integration, they can simply say integrate for us 1 divided by 1 minus x squared dx. So as you studied in integration 1, integration is the reverse process of differentiation, meaning that when you integrate this, you must be able to come to this. So you must be knowing some of these expressions, such that when you reach in integration, then you shouldn't be seeing stars. You should be like, yes, I know this one from differentiation. This one comes from the differentiation of sine inverse. When you meet something like this one comes from the differentiation of cos inverse. When you meet something to do with 1 over 1 plus x squared, that one comes from differentiation of tan inverse. So you must be knowing some of these expressions. Okay, so let us see. If we have sine inverse of x, how do we differentiate it to come to 1 divided by the square root of 1 minus x squared? That is what we want to look at. The procedures are very simple. So we want to differentiate a sine inverse of x. We want to differentiate that. So what we shall do is we shall relate a y to represent sine inverse of x. If y represents sine inverse of x, then bring up this sign back this side. So sine of y will be equal to x. If sine of y is equal to x, then from here differentiate on both sides with respect to x. So what we are doing here is differentiating on both sides with respect to x. If you do that, then what do you get when you differentiate sine of y? I will, before I come to that, I will ask, if you have y squared, you are differentiating y squared with respect to x, what do you get? You must have looked at that when you were looking at implicit expressions, implicit functions. Anyone tell us what you get when you differentiate y squared with respect to x?
Y.
You get 2y divided dx.
You get
2y.
You get 2y
dy dx. dy dx.
dy dx.
What is that dy dx?
That is very important. When you differentiate y squared with respect to another variable, you must show that you didn't differentiate y with respect to y. If you had differentiated y with respect to y, you would simply get 2y. But because you are differentiating it with another variable, x, after differentiating this one here normally, this is 2y. So this one here is like you are differentiating with respect to y, your y squared. This means that you are differentiating with respect to y squared. But again, you are multiplying by dy dx because your interest is to have this one differentiated with respect to x. So when you look at this and this still cancels, and you are having like d dx of y squared. So that is what it means. So when you are differentiating y squared with respect to another variable, make sure you differentiate that one with respect to y first. That is getting 2y, but you must put dy dx because you are differentiating it with another variable. So that's why we are saying d dx of y squared is 2y dy dx, not 2y alone. When you put it as 2y, then it is as if you are differentiating this with respect to y, which is not true. So the two sides will be not equal. So with that, can we now differentiate this? What do you get when you differentiate sine of y? Anyone
Cos
tell
of
us?
y.
You will get
Dx.
cos
Cos of y.
cos of y
Cos of y divided
d
dy dx.
cos of y dy dx. So you differentiate this with respect to y, but you must multiply with dy dx. This should be equal to differentiate this with respect to x, and you will get 1. I hope that one is very clear for all of us. Now, from this given point, dy dx, if I divide it through by cos of y, it will be 1 upon cos of y. So we are having dy dx as 1 upon cos of y. But I want to get cos of y in terms of sine because I have sine y as x. So I want to eliminate cos of y. To eliminate this cos of y, what I can do, I will borrow the knowledge from the Pythagorean identity, which says that if I have cos squared of y, I add there sine squared of y, I will get 1.
1.
So meaning that if I have cos squared of y, it is same as having 1 minus sine squared of y. And likewise, when I take square root on both sides, so it means cos of y can be represented by 1 minus sine squared of y.
1.
I hope that is okay. So from this given point,
Yeah.
where I have dy dx, I can put this as 1 divided by the square root of 1 minus sine squared of y. And this would be same as 1 divided by the square root of sine. Sine of y, we have it here. Sine of y is that. So this is 1 minus x squared. So this is dy
That's where.
dx. This implies that therefore, when you differentiate sine inverse of x, you get 1 divided by the square root of 1 minus x squared. Are the procedures very okay? Okay. Now, let us therefore come to another expression. We need to differentiate this. This and this one are almost similar procedures. You can always see that the difference is only the minus. So you should be able to try out that one. Using the similar procedures, there is nothing which is changing here. Cos inverse of x, bring cos this side, differentiate cos of y, get negative sine of y dy dx. So that is where the negative will come from. But don't forget to have negative sine of y dy dx equaling to 1. So this should be very okay. Following similar procedures, you should be able to try this one out. Okay, so I hope you will try that. Let us talk about the derivative of tan inverse of x. So the derivative of tan inverse of x. So when you differentiate tan inverse of x, you are expected to get 1 divided by 1 plus x squared. So let us look at that. So we shall follow similar procedures. 1, we let y to represent tan inverse of x. If y represents tan inverse of x, then what will be tan of y? So bring tan this side, get tan of y equaling to x. Then from this given point, differentiate. Differentiate with respect to x on both sides. Someone should tell us, what do you get when you differentiate tan of y?
Cot.
You get
Cot.
cot.
Six squared y.
You get
Sec
sec squared. When
Sec
you
squared.
differentiate tan, you get sec squared y. But do we stop there?
No?
Then dy
The x.
dy dx. Because you are differentiating tan with respect to x, not with respect to y. If it was with respect to y, there is no need of putting this. So sec squared of y
Okay.
dy dx is equal to 1. So
That's
from there, dy dx will be same as 1 divided by sec squared of y. So
x. Y.
y. So from here, you should now get the relationship between sec and tan. So what is the relationship between sec and tan? Anyone who recalls that?
Sec and tan.
1 plus tan squared y is equal to
We know
x
that
squared
1
y.
plus tan squared of y is same as
Sec square of y.
sec
X
squared
squared
of
of y.
So that should be clear for all of us now. So I want us now to have the y dx as 1 divided by sec squared. Sec squared we have seen is 1 plus tan squared of y. So we have already seen that tan is x, tan of y is equal to x. So if tan of y is equal to x, then it means this will be x squared. So dy dx is equal to 1 divided by 1 divided by 1 plus x squared. So in other words, whenever you differentiate tan inverse of x, you get 1 plus x squared. So that is how we differentiate inverse trig functions. Unless there is a question, then we can look at one more question, not necessarily having tan inverse of x, tan inverse, those are very direct. So we can look at some few other questions that consist of inverse trig functions. Okay. So is that one very clear to all of us? I see someone having a hand here. Kadowe, you have a question? I see your hand up. We are not hearing you. Maybe you can try to unmute. Okay, so let us look at this question. The question says, show that when you differentiate, show that this is show that
Aku yang pakai pandu, dia tak pakai pandu je. Kasih dia makan boleh.
So that is our question there. I show that dy dx is same as 2 divided by 1 plus x squared if y is equal to tan inverse of 2x divided by 1 minus x squared. So let us try out this together, following the similar procedures that we did. So what we shall do is, so we are given y as tan inverse of 2x divided by 1 minus x squared. So from there, we shall take tan this side, and it becomes tan y, which is equal to 2x over 1 minus x squared. I hope we are together there. From this point, we shall differentiate with respect to with respect to x on each of the sides. Now, from this given point, when you differentiate tan y, you get sec squared of y dx. Now, let us look at this. I want us to do this one at once. We have v du dx. Is it okay? Our v is 1 minus x squared. What is du dx? U dx, this is representing u, this is representing v. So we are applying this in v du dx over u dv dx, quotient rule, over v squared. So 1 minus x squared times du dx. Du dx is differentiating 2x, which will give us 2. Then minus u is 2x. dv dx, what do you get when you differentiate 1 minus x squared?
Negative 2x.
You get negative 2x. So we shall divide the whole of this by v squared, which is 1 minus x squared.
X squared in brackets squared.
Okay. So we are all at that given point. Now from there, let us try to simplify this upper one. I want us to simplify it from here, then we just transfer the answer. This is 2 minus 2x squared. This and this will give us a plus 4x squared. Is that one okay? So this will be 2 minus x, this and this. That is plus actually. Plus 2x squared. So that is what we shall have here. So here we shall have 2 into 1 plus x squared divided by 1 minus x squared, again squared. So that is what we shall have. Okay, so from that given point, Let us again, we remember we have sec squared y dx equaling to that. So I want to have that as sec squared y dx. So this Kadowe man. Don't know what is happening with him there. So sec squared of y dx is equal to, let us try to have this. This is 2 into 1 plus x squared, 2 into 1 plus x squared, over, this is over 1 minus x squared again squared. So this is 1 minus x squared again squared. So I want us now to divide it through by sec squared. So dy dx will be equal to, dy dx will be equal to 2 into 1 plus x squared over 1 minus x squared again squared. So we are dividing through by sec squared, so we shall have over sec squared of y. Okay, so from here, let us have a sec squared of y. So we have already got a tan of y as this, 2x over 1 minus x squared. So I want us to have now sec squared somewhere here. Let us try to simplify the expression for sec squared of y. We know that sec squared of y is 1 plus tan squared of y. So it means here we shall have 2 into 1 plus x squared divided by 1 minus x squared again squared. Then times 1 upon sec squared is 1 plus, this is 1
plus.
Okay, this is 1 plus
Tan squared y.
1 plus tan squared of y. That is what we shall have. So from here, we shall have this as 2 into 1 plus x squared over 1 minus x squared again squared. And then times 1 over 1 plus tan squared. I want us to get that one at once. 1 plus tan squared, we already have our tan as this. So I want us to have it as 1 plus 2x over 1 minus x squared, the whole of this squared. I want us to simplify that. So this will be 1 plus, this is squared, so that is 4x squared. This one here is 1 minus x squared, also
squared.
Also squared. Okay.
Yeah.
So let us now try to get the LCM. If you try to get the LCM here, you will get 1 minus x squared, which is squared, plus 4x squared. The whole of this divided by 1 minus x squared, again squared. So this is coming from sec squared. I want us, instead of having this, we place there this one. So we are placing there 1 minus x squared squared plus 4x squared divided by 1 minus x squared. The whole of this is squared. So when you look at this, you realize that this expression which is here, this one and this one will be cancelling. Is that okay?
Yes.
So if these two cancel, then we shall remain with this one and this one. So that is what we shall remain with. So we have this and this. So this one will be same as having, this will be same as having 2 into 1 plus x squared divided by 1 minus x squared squared plus 4x squared. I hope that is what we are having here. So that is what we are having. Okay, so let us try to simplify this expression and see what we shall get. Okay, so we try to simplify this. So we have this one, 1 minus x squared again squared can be simplified as this is 1. So 1 times 1 squared, I hope you know how to expand a minus b squared. This is same as a squared minus 2ab plus c squared. So this is 1 minus 2 into 1 into x squared, then again plus x to the power of 4. Okay. So which we shall place here. So we shall have 2 into 1 plus x squared divided by 1 minus 2x squared plus x to the power 4, then plus, is that one okay?
Yes.
Okay, I hope no one is lost. We are trying to simplify and see if we can get the required answer. We are given that we need to show that when you differentiate this, you get this. So we must work towards getting this answer. So that is why we are struggling much to get there. Okay, so this will be same as 2 into 1 plus x squared. I want us to simplify this. This is 1 plus 2x squared plus x to the power of 4. So when you look at this, what do you say about the expansion for this? So what is this one coming? Where is this one coming from? This is expansion of some given expression. I hope we can easily compare it with this. You realize if I place a plus here, then I will get this. So in other words, this should be what? This should be a plus. Is that one okay? So when you look at this, this is same as having 2 into 1 plus x squared divided by 1 plus x squared, the whole of this squared. Is that one okay to everyone? Please, in case you are lost, you let us know. So this is still our dy dx. Remember, this is dy dx. So what we are having here is still dy dx. This is still dy dx. So dy dx will be equal to, when you look at this, it will cancel with one of this, and it will be 2 upon 1 plus x squared. And this is actually the required answer. So that is what was basically required from us. So that is basically what was required, and I hope the procedures are relatively the same. Only that if this the angle here changes, then you should still follow the same procedures. So whenever you get x squared, make sure you turn it back, put it in terms of turn again. So try to create the relationship with what you have here and what you have got at this given point. So that is how we deal with inverse trig functions. So Kadowe, please try to mute.
The time you called me was just reading the sentence.
Kadowe, please try to mute.
You can't do it.
So you should be in a position to try for me this. It says that show that when you differentiate with respect to x, sine inverse of 1 minus x squared over 1 plus x squared, you should be able to get -2 over 1 plus x squared. So this is your trial question. Please try to do that. See if you are able to get the answer there. The answer is already there. So try to see if you differentiate these following similar procedures, whether you will be able to come up with that. So likewise, you will try to differentiate for me the following as well. So you have a sine inverse of 2x minus 1. We have a tan inverse of 1 minus 3x. Try to follow similar procedures and see if you are able to come up with the answer there. And lastly, try for me this show that if you get an inverse almost similar to what we have done, when you differentiate this, you will be able to get 1 upon 1 plus x squared. So try these numbers out, and in case you need any guidance on some of these questions here, please try to contact me here. This is my WhatsApp number, 567840530068. So that is the WhatsApp number. So try these questions out. In case you are able to get the answer, then you send for me the solutions and you are working. Make sure you don't forge the answers because you have this one here. Some people have that tendency because they are having the answer, so the procedures are wrong. They are having a correct answer. So make sure you follow correct procedures and see if you are able to get these answers. So please try to contact me with some of the solutions that you are able to get there. And in case of any challenges, also try to link up with me, and I will try to guide where necessary. Otherwise, that is where I want us to stop for today. We have really talked about something to do with further differentiation, and basically this is a very good foundation for us to understand better differentiation too. So try as many numbers as possible. Otherwise, have a good night, and we meet in our next lesson. Thank you so much. All the best.